In this third video on integration techniques, we'll be taking a look at integration via substitution. So when do you use integration via substitution is when the function they want you to integrate are rather unpleasant looking and extremely difficult to integrate via a normal means. So you have to make use of substitution, usually a trigo substitution, to make the function look nicer and hence easier to integrate. At JC level, you don't have to worry. They will always tell you when you need to use substitution and what to substitute. So as long as you see the words use the substitution, they will tell you what to substitute in. This is when you know it's your cue to make use of these infos to integrate a very difficult looking function. So let's just go ahead and do the first question here, and then we will go through some of the techniques. Okay, first one, use the substitution x equals to a secant theta to find the exact value of this definite integral. So let me just copy it down from a to 2a of square root x squared minus a squared over x dx. We have to recognize there are three things for us to change. Because x is the variable here, we are differentiating this with respect to x. We will need to incorporate theta to replace all the x we see. So there are three places where x occurs. First of all, it's the content, the function itself. We will need to substitute this away for theta. Second item is these boundaries. These boundaries are x values. In other words, we are integrating from x equals to a to x equals to 2a. These boundaries are your x values. We also have to sub them away. Third item would be here, what we are integrating with respect to. From dx, we need to change to d theta. So let's do this step by step and fully change this function in x into an entirely clean function in theta. First step, replace the content. So I'm going to leave these two blank because I haven't found out what they are in theta yet. Here, I will have a squared secant square theta minus a squared divided by a secant theta. Very easy. Every time you see an x, replace by a secant theta. Second step, dx. What has dx turned into? In order to do that, you have to start a side project. Start off with what they gave you, x equals to a secant theta. Here, we will be able to find dx, d theta. It will give you a secant theta tangent theta according to MF26. You can go MF26 and dig out what is the differentiation of secant theta. Once we have done with this, dx, get this step, do not write it out, think about it. Dx will be equals to this times d theta, right? You can sort of cross multiply. I use inverted commas because you're not really supposed to do that, but it's an easy way for you to remember. So once you have cross multiplied this over, you will get here a secant theta tangent theta d theta. That's what dx is. So I have replaced dx with these whole string. Third item, we got to change the boundaries. For this particular value, x is equals to 2a, right? We have to find a corresponding theta value. So if x is equals to 2a, this means that a secant theta is equals to 2a. Secant theta is equals to 2. This means that cosine theta is equals to half. So theta is just pi over 3, 60 degrees. Do not change place wherever you took the 2a from, which is the number on the upper bound. Just write pi over 3. Sometimes you'll get this number bigger than this number, and that's okay. Just put them in the same place where you found them. Next one, x equals to a, right? So here, equals to a. This is just a, so this is just 1. Cosine theta is just 1, so theta would be 0. So now we have done all three things. We have changed the boundaries, we have changed the function, we have changed the dx into d theta. Let's clean this up. Here will be 0 to pi over 3. This is gone. A is gone as well. Take a look at the inside. Inside, you can write it as square root of a square. You factorize out the a square within the square root to give you secant square theta minus 1. This turns out to be just tangent square theta, a square. So when you square root it, you just get a tangent theta. And then here you have another tangent theta, d theta. No more denominator, so this is just like that. So next step, we pull out the a, and we are left with just 0 to pi over 3 tangent square theta d theta. So then at this point in time, we have turned something that looks pretty unfriendly into simply a trigonometry. We have to now integrate this trigonometry, tangent square theta. Now you might be thinking, oh, integrating trigonometry is not an easy task. It's actually pretty easy. You only have to classify them properly in a table that looks like this. Let me just quickly go through with you what this table is. On the left-hand column, you see all of these are your 6 basic trigonometry and its integration. So the 6 trigonometries are sine and its co-version, which is cosine, secant, cosecant, tangent, and cotangent. First two, you already know from Sec 4. This column, you will get the basic trigonometries, whereas this column, you get the basic trigonometries squared. Each of them has a certain technique to do. The 4 here you see are on the MF26, basically tangent, secant, cosecant, cotangent. You can find this on MF26. There is no need for you to do any conversion, no need for you to do any memorization. The first two, sine, integrating sine give you negative cosine, and integrating cosine give you positive sine. These two are from secondary 4. This column here, it's rather easy. And on the right hand side, you actually get the basic trigonometries squared. Let me just focus on two very easy ones, which are these two. These two are actually done in secondary 4. Integrating secant square, you have to remember is actually tangent x, because differentiating tangent x gives you secant square x. Similarly, differentiating cotangent x gives you negative cosecant square x. So this here, the second last one, it's also sort of taught in Sec 4. The red color boxes are those that are taught in Sec 4. Then let me talk about sine square and cosine square. Remember, every time you have to integrate sine square or cosine square, always think about cosine double angle. Use cosine double angle formulas. Meaning, use the cosine double angle that involves sine square x or cosine square x. So let's say you are asked to integrate sine square x, you will turn this into this. Then make sine square x the subject. In other words, sine square x is equals to, so bring this over, you get 2 sine square x equals to 1 minus cos 2x. And then divide both sides by 2 to give you this. Now use this in place of sine square x for easier integration. Similarly, cosine square x, if you're asked to integrate cosine square x, choose the cosine 2x formula that involves cosine square x. In other words, this one, the cosine 2 cosine square x minus 1, and then you make cosine square x the subject. It will be equals to cos 2x plus 1 over 2. Replace this here, you have a much easier time integrating it. Final two, which are tangent square x and cotangent square x, you have to go through secant square x minus 1 and cosecant square x minus 1. In other words, the Pythagorean formula for trigonometry. The Pythagorean formula for trigonometry is these three: sine x plus cos square x equals to 1, tangent square x plus 1 equals to secant square x, and cotangent square x plus 1 equals to cosecant square x. These three, it's not on the MF26, you actually have to memorize them. But as of now, I believe you should be pretty familiar with these three already. Once you convert it into cosecant square and secant square, then you can use this red color box to actually help you. So remember, everything on the left hand side is easy. The 6 basic trigo, the first 2 you know in Sec 4, the last 4 you have it on MF26. For the squares of the basic function, sine square, cosine square, tangent square, secant square, cosecant square, and cotangent square, the secant square and the cosecant square, these two are already learned in Sec 4. The other two, the sine square and the cosine square, go through cosine 2x formula. Tangent square and cotangent square, we will go through Pythagorean formula, convert it into cosecant square and secant square, then use these two here to further integrate it. So back to our question. Integrating tangent square, all we need to do now is to turn this into secant square theta minus 1 d theta, and then this question becomes really easy because this is integrating tangent secant square gives you tangent theta minus theta from pi over 3 to 0. This will just give you a tangent theta, tangent pi over 3 gives you root 3 minus pi over 3. Subtract away tangent 0, which is 0, minus 0, which is also 0. So that leaves you with this answer here. Now, I'm going to give you a bonus question. The bonus question would be, what if this question here is not bounded, meaning there are no boundaries, then you will have to actually make use of the substitution to sub back. Meaning once you get to this stage, once you get to integrate secant square theta minus 1 d theta, we will get a tangent theta minus theta, right? There are no boundaries, so there are no values for us to sub in. What do we do here? We will now have to turn this back into x, because theta is just like a passenger that we actually just make use to make the question simpler. We have to incorporate back the x, which is the original question. It is still with respect to x. So what we do here is you take note of what you use to substitute, which is x equals to a secant theta. And we have to reverse back and find out what is tangent theta and find out what is theta. To find that out, every time we have this, remember the golden rule is to draw the right angle triangle. Find out what is theta. Theta will be the angle, and we're applying a trigo to it, right? Let's do some manipulation. We should get this. X over a equals to secant theta. Secant theta is actually hypotenuse over adjacent. So x is the hypotenuse, a is the adjacent. X is the hypotenuse, a is the adjacent, which makes this square root of x squared minus a squared. Question now, what is tangent theta? Tangent theta is simply square root x squared minus a squared over a. And what is theta? Theta is simply secant inverse x over a. And that's the answer if we really want to force it back, and when there are no boundaries. When there are no boundaries, you have to incorporate back x into your answer and substitute away all the thetas. Next question, same thing, so I'm going to quickly go through this without diving too much into the content. Integration from 0 to 6 over 5 of root 1 minus x squared over 4 dx. Three things we need to change: boundaries, content, and dx. First of all, let's start off with this. X equals to 2 sine theta. Dx d theta would be 2 cos theta. And dx here would be 2 cos theta d theta. 2 cos theta d theta. What about content? The content would just be 1 minus x squared would give you 4 sine square theta over 4. Simplifying this would just give us, this is gone. You're just left with this. 1 minus sine square theta is actually cosine square theta. Square root it just gives us cosine theta. What about the boundaries now? Boundaries, just change them. When your x value, it was 0, 2 sine theta is 0, so theta is 0. So 0, this remains 0. What about 6 over 5? X is 6 over 5. 2 sine theta is 6 over 5. Then sine theta is 3 over 5, which leaves theta as sine inverse 3 over 5. I'm going to leave it like that because there is no nice value for sine inverse 3/5. It's just a decimal. I'm going to leave this here, sine inverse 3 over 5. Then let's clean this up. Cosine theta, 2 cos theta can be written as 2 cos square theta. I'm going to move the d theta closer for nicer presentation. This, I can pull out the 2 and we're just left with this. Remember how to do cosine square theta? How do you integrate cosine square theta? We have to go through cosine double angle. Always remember cosine double angle. Now, the one that we want is this one. Cosine 2x equals to 2 cos square x. Okay, let's use theta minus 1. So we're going to make this the subject, which will give us cos 2 theta plus 1 over 2. Putting this back in here, we will get 2 integration cos 2 theta over 2 plus 1 over 2. What I did here is I split this fraction up into 2 pieces, which will give us just, now integrating this will just give us sine 2 theta over 4 plus half theta. From 0 to sine inverse 3/5. So now what I'm going to do is I'm going to replace that sine inverse 3/5 by A. Okay, it's because I'm tired of writing sine inverse 3/5 all the time. In fact, later you will see that it will actually help us solve the question. Simplifying this some more would give us 2 sine 2 theta gives you 2 sine theta cos theta. Cancels off with the 4 to give you sine theta cos theta over 2. Everything remains the same. Multiplying by 2, I will get simply just sine theta cos theta plus theta from 0 to A. Now simply sub in, I will get this sine A cos A plus A, minus away, sine 0 is 0, so this thing is gone, 0, so I actually don't have to write anything else. Come back to the question. Just now we let A be sine inverse 3/5, right? How do I know what is sine A? Very simple. Bring this back here. I'll get sine A equals to 3/5. So this number here is just 3/5. What about cosine A? Similarly, like we did previously, draw the triangle. This is angle A, opposite over hypotenuse. That leaves the adjacent length to be 4. So cosine A is simply 4 over 5. And of course, A remains unchanged. It is still sine inverse 3 over 5. Simplifying this will give us what they want, 12 over 25 plus sine inverse 3 over 5. Thank you. That's it for this video.